Hey guys, we are in the final day of lesson 2, and we're just going to keep on going with different techniques of solving equations. We're going to hit several more today. The first thing I want you to notice is that this is going to be in radians, and we're going to do factor by grouping. So personally, what I do is I don't know, some teachers teaches like the u substitution as sine of x. However you want to see it, I just look at this as 2x cubed minus x squared equals 1 minus 2x. And so what I do, and I talked about this in the last video, is I keep the sign of x out until later. So instead of solving for x, I'm going to solve for sine of x. So I know that moving forward. If you want to go ahead and just like use the sine of x as you go through, that's fine. I just like to focus on the algebra first and then just kind of transfer over to the trig. But it's just whatever you want. We're going to factor by grouping. So I'm going to move this side over. So I have 2x cubed minus x squared minus 1 plus 2x. And we're going to group these together. And I'm going to factor out an x squared. So notice I kind of flip-flop these to keep them consistent with that. And so I have x squared plus 1 equals 0. And I have 2x minus 1 equals 0. So this one, x squared equals negative 1. So if you take the square root of a negative number, you're going to get no real solution. So we're just going to stop it there. Over here, I'm going to have 2x equals 1 divided by 2, so x equals 1/2. So I can do something with that. So I'm going to go ahead and plug it in as the sine of x equals 1/2. So I'm coming back up here and substituting that in for x. Okay, so I'm going to multiply both sides by the sine inverse, and I get x equals sine inverse of 1/2. So you should be seeing that or thinking that 1/2, that's on the unit circle. So the sine of 1/2, that's like a 30-degree angle, or like pi over 6. I also notice that it's positive, so I'm going to be dealing in quadrants 1 and quadrants 2. So in quadrant 1, it's going to be pi over 6, and in quadrant 2, it's going to, I don't even know where that came from, pi over 6, and in quadrant 2, it's going to be 5 pi over 6. And again, just using that unit circle. Okay, so number 2 is very similar. Go ahead and see what you can do. I'm going to warn you. Think about that one. So go ahead and try it out. I'm kind of interested to see what you would do with that. And then we'll just kind of take it from there. Okay, so this, I needed to get it into terms of sine. And so this is 1 over sine. So for my algebra purposes, I just called it 1 over x. And so that was kind of an issue. I had to think about what to do there. And so I multiplied everything through by x. So it bumped all these up by x, and those x's cancel out to leave me 1. Okay, so we're still going to do the factor by grouping. So I think I'm going to turn you loose because this one is the same as like this up here. So see if you can follow my steps up here and take it from here. So I'm going to push pause, come back, and we'll talk about it. Okay, so I believe we ended up right here. And so when I did factor by grouping, I ended up with this. And when I solved it, 2x squared right here, minus 1. When I solved that, I ended up with this. And I rationalized the denominator to get to that. So that's what I plugged in sine of x for. And so notice that you have the plus or minus. So that means that it's going to be in all 4 quadrants. And square root of 2 over 2, that's on the unit circle as 45 degrees or pi over 4. So that's where I got those values. And so the same thing over here. So I went through, let me do this in different. I went through this process and I ended up with x equals -1/2, which I transferred sine of x equals -1/2. And I multiplied by both sides, and I saw that -1/2 is on the unit circle, or 1/2 is. So the sine of 1/2, we're talking about 30-degree angle, or like 5 or 6. But this was negative, so it's in quadrants 3 and 4. And so these are my values for that. Okay, so for the next part, we're going to use the quadratic formula. And so treat this as you would just like a regular quadratic formula. So like the coefficient of the squared term is 1, the coefficient of the x term is -5, and your constant is 1. So go ahead and do the quadratic formula and see what you get for your answer. Okay, so you should have gotten 5 plus or minus the square root of 21 over 2 equals x, but this time it's going to equal the sine of x. So I'm going to split this up into the sine of x equals 5 plus square root of 21 over 2, and sine of x equals 5 minus square root of 21 over 2. So my next thing that I do is I take this and I see what it is as a decimal. So go ahead and do that for both of those. Okay, so I got about 4.79 for this one, and I got about 0.2087 for that one. Okay, so the reason I do this is because look at this one. So I'm eventually going to say sine inverse of 4.79. So remember we talked about anything over 1 you can't do for sine, so this one is no solution. So if this were like tangent or something, I wouldn't care as much, but that's kind of a big deal. Okay, so over here, this one works, but if I didn't like find the decimal, I wouldn't know if this is a positive or a negative. So that's going to affect which quadrants they're in. So you need to know if you're doing 1 and 2 or 3 and 4. So by me finding the decimal and seeing that it's positive and seeing that I can go ahead and do it, then I know that I'm in quadrants 3 or 4. So when I simplify this, I'm going to get sine inverse of this. And so when I type that in my calculator, I end up getting about 0.21. So x equals 0.21. And then when I add, sorry, it's in quadrant 2. So I'm going to say pi minus 0.21. And that ends up being 2.93. And one more thing, it is a total coincidence that like this and this are similar. If you like when you type in your calculator, you'll see that they're not the same, but it's just the way it worked out. It's not the same number. Okay, so go ahead and try number 2 on your own, and I'll work through it, and we'll see if we end up in the same spot. Okay, so the first thing I did is I got here and then I just simplified. So you can simplify the 8 as 2 square root of 2, and then I just simplified it. So I got to here. If you got to here and stopped, I think that's okay. Like, it's not going to affect your answer at all if you type in your calculator correctly. So like, for instance, down here, it would just be like 4 plus square root of 8 over 2 and 4 minus square root of 8 over 2. Something else that I said before that I didn't really worry about this one. So on this one, I was really interested in finding the decimal equivalent. On this one, I wasn't too worried about it because I knew that this was positive, and I don't really care if it's bigger than 1 because it's tangent. And then I knew that this one was also positive because if you take 2 minus the square root of 2, I already knew it was positive. So I really didn't need to find the decimal equivalent. I mean, you can, there's nothing wrong with that. So since they're both positive, notice that like all 4 of your answers are going to be in that first and third quadrant. So this is my reference angle for this side, and this is my reference angle for this side. Okay, so for the final one, we are going to talk about so basically factoring, but using substitution. So the problem with this one is notice how this is like sine squared and this is cosine. So what you're going to do is you're going to start here and you're going to put this in terms of cosine. So if you'll remember like the mama function was sine squared theta plus cosine squared theta equals 1. So sine squared is 1 minus cosine squared theta. So in this case, it would be x. So that's where I'm going to start off. So I'm going to say it's going to look like that. So I'm just going to do a bunch of algebra right now. So 2 minus 2 cosine squared x. And so let me just combine the like terms. I'll come over here. So I have negative 2 cosine squared x equals 3 cosine of x, let's see, minus 1 equals 0. And I don't like that negative there, so I'm going to go ahead and just multiply by negative 1 and just change the signs. Okay, so at this point, I think I'm going to look at it like this and factor it. It kind of just helps my brain process that. So go ahead and I want you to end up with cosine x equals cosine x equals, and we'll see if we meet up. Okay, so I ended up with the cosine of x equals 1/2 and the cosine of x equals 1. So if I multiply this by the cosine inverse, I end up with x equals cosine inverse of 1/2. So it's jumping out at me that this is on the unit circle. So we're talking about, let's see, we're still in radians. So we're talking about a 60-degree angle, which is pi over 3. Okay, and so it's positive. So I'm talking about quadrants 1 and quadrants 4. So in quadrant 1, it's pi over 3, and in quadrant 4, 5 pi over 3. So x equals pi over 3, x equals 5 pi over 3. Okay, let's come over here. So I like to think about it as a coordinate plane. So I want my x to be 1. So that's the only, because over here it's negative 1. So that's the only place that x equals 1. So when I have x equals cosine inverse of 1, my answer is just going to be x equals 0. Okay, so notice the process. The first thing I did is got everything in the same terms, and then I factored it. So I want you to do the same thing here. So the secant squared needs to be in terms of tangent, and then factor it. So go ahead and do that, and we'll pick up here in a second. Okay, so this is my work so far. So I saw that secant squared x is the same thing as 1 plus tangent squared x, and that got that in the same term. So here's my process here. I just simplified, and then I just focused on the algebra of it, and I ended up with x equals 3/4 and x equals -1. So I'm going to say tangent of x equals 3/4 and tangent of x equals -1. So I'm just going to rewrite that over here. And I'm going to go ahead and multiply both sides by tangent inverse. And so I'm left with x equals tangent inverse of 3/4 and x equals tangent inverse of -1. So this one I know is on my unit circle. So I guess we can just start there. So think about tangent